This video is intended to introduce hypothesis testing with z-tests. This is also Chapter 7 in your textbook. Now, the 6 steps of hypothesis testing are introduced in a separate video, but for this video I'm going to show you how to use the z-table and what that means in terms of finding percentages. Okay, so as we talked about in Chapter 6, we have benefits from standardization. It allows us to put our variables on the same scale so we can make fair comparisons among them. The z-table, because the z-distribution is a specific type of normal distribution where the mean is 0 and the standard deviation is 1, can allow us to find the percentage of scores that fall between the mean on a given z-score. You can also find the percentage of scores that falls between a z-score and the tail of the distribution as well. So in order for us to find a percentage or a percentile that's associated with a particular z-score, then you start by taking that raw score and converting it to a z-score, which we talked about last time in Chapter 6. And then you look up what that area under the curve is in the table. And the table will give you either the area between the mean and z and the area beyond that z-score and into the tail. So let me show you what this looks like by coming over here to look at a copy of the z-table here. So your z-table is going to be the first table in Appendix B, and you'll notice here that it's got a little picture at the top of each of these two columns. So the first column is your z column, so that lists all the possible z-scores. And then it will give you either the mean to z, percent mean to z, and you can see that area is shaded here, or it will give you the percent that falls beyond that tail. Now you'll notice that if you summed the mean to z column and the percent and tail column in a given row, it will equal 50%. And that's because half the scores fall above the mean and half the scores fall below the mean in the z-distribution. That's what it means to be symmetrical, or at least part of it. So let's say that we had a z-score of 0.67. So we would look in that first column, notice that there's two sets here, and 0.67 just happens to be at the bottom of this particular table right here. So if we wanted to know a score of positive 0.67, what that particular percentile would be, we would look in that first column that says mean to z, and then we would have to add in this additional 50% because this is a positive z-score. So if we come down here and we see that mean to z is 24.86%, okay, and then we have to add 50%, what we end up with is 74.86%. The other way that you could get that percentile would be to say, okay, well, I know that 100% of the scores fall underneath this z-curve. So all of this area equals 100%. And I could take that 100% and subtract out the area in the tail. So if I came down here and I subtracted out this 25.14, then I would get 74.86. So that is how we use this z-table. You'll also notice that, so that's just the first page of this table. It's actually several pages long because if you notice here, it goes up to 1.87 on the second page, and then we get to the end of the z-table and it maxes out at about 4.5. What you'll see is that it says, oh, there's nothing that falls in the tail here. And that's not entirely true. This particular table goes out to 2 decimal places. And so what that means is that we can't actually register the percent in tail as being greater than 0.01. And so any value that we have that's more extreme than that is going to appear to be 0. But remember that the curve for the z-distribution is actually asymptotic. And what that means is that that line, that curve, never actually touches the x-axis. It never actually gets to 0. So the probability never becomes 0. You can still get a z-score of 10. It's really unlikely, but it's still possible. It's just that that value is going to be much less than 0.01 or even 0.005, because 0.005 we would round up. Okay, so let's come back over here, to where we were. We'll continue. All right, so we've talked a little bit about how to use that z-table. We can also take a percentage from say, oh, this person is the 85th percentile, right? So we could use the z-table in reverse. So we could take a percentage and convert it to a z-score. So let's do that for a minute here. We'll come back to our trusty z-table. And if we said, okay, we want to know what the 70th percentile is. And again, okay, those pictures are only on the first page, but we can come back and look at it real quick. So again, if we wanted to know what the 70th percentile is, we know it's going to be above the mean because it's positive. It's above 50%. Okay, and so we would take 70 and we subtract out that 50% that falls below the mean. So we know that what we need then is 20% to fall between the mean and z. So percent mean to z needs to be 20%. So I'm going to look down that column here. And if we come down here, we see that we get 20.19 at 0.53, and we get 19.85 at 0.52. So I'm going to go with 0.52 because that's the closer of the two values to 20%. So we know that if you fall above the mean a little over a half standard deviation, then you're going to be at the 70th percentile. We could do the same thing if we wanted to know, say, what the 15th percentile is. And in this case, we'd want to look at the percent in tail. And if you can imagine this being flip-flopped as a mirror image, then what we're looking at is, if we want to know 15% of the scores fall in the lower tail, it's going to be a negative z-score because we're talking about below the mean. And so we're going to look in that percent in tail column, and we're going to look for 15%. And it's not on this table because it goes all the way up to 25. So we're going to have to go to the next page and look in this percent in tail column. And we're going to look for 15%. I'm going to scroll down here. Okay. So we have 14.92 right here. That's the closest we're going to get to 15. Because 0.15 is further away than 0.08. So I would say it's a z-score of negative 1.04. Remember, because it's below the mean and we're saying the 15th percentile. So that's another way we can use this z-table. And we'll come back over here. Okay. The second part of that would be, let me go back for a second here. The second part of that would be then, okay, so let's convert that z-score to a raw score using the formula. And let me see if I can get it to let me, here we go, here's a pen. Okay, so let's say then that we have this negative 1.04. This doesn't work as well when I'm not using the touch screen, but that's okay. Whew. Okay, 1.04. Then what I need to do is, let's say that our standard deviation is 10 and our mean is 50. Ooh. Yeah, not so good when I'm trying to write with my finger. There we go. So this is our standard deviation. Oops. Yeah, that's 50. Okay. So if we wanted to take this z-score of negative 1.04, we would have to multiply it by the standard deviation, which is 10, and then we'd need to add this mean of 50. And you can already see that it's going to be below the mean because we've remembered our z-score is negative. So negative 1.04 times 10 is negative 10.4. And then we'll add the 50 in, which means that it's going to be So 50 minus 10 is 40, and then we have to subtract out this 0.4, so that gives us 39.6. Okay, so that's a 9, not a 7, or a 1. Okay, so that's what it gives us here. Oops. All right, so you'll want to be drawing the curve, especially in the beginning. It's a lot easier if you can say, oh, I know what this looks like. Where is my cutoff? So if I draw my normal curve, yeah, that looks kind of skewed, but let's pretend it's normal. Then I can say, okay, well, I know this area under the mean. We want this area right here. Okay. And so if we know what this cutoff is, then we know which area we need to be looking at. So it helps you keep what you're doing clear in your memory. It helps minimize your errors. It's a practical reference for you to remember, oh yeah, this has got to be negative or positive, or which column should I look at? And it helps condense the information. So I really do recommend, even if you don't upload any drawings that you make, that while you're working the problems, you do make drawings. Let's go over here. All right, so again, here's that standardized Z distribution. And remember, we have 34% that falls between the mean and 1 standard deviation, 14 between 1 and 2, and 2% falls beyond or in that 2 to 3 range. So that's what we're working with. Here's an example of getting a percentile for a positive Z-score. If your Z-score is 0.98, you know you have 50% that's below the mean, and then you look at this percentage mean to tail, and if you look it up in that Z table, you'll find it's 33.65%. And we need to add those two together then in order for us to get 83.65% as the percentile for a Z-score of 0.98. Now, if we wanted to know, say, what percentile of scores falls above a particular Z-score, so how many people performed better than someone who got a Z-score of 0.98 on an exam, then you could look at that percent in tail, or you could say, okay, 50% minus 33.65 gives us 16.35%. We can also talk about calculating a Z-score at least as extreme as a particular Z-score. And this will come in handy when we start doing hypothesis testing, as we're going to find Z-score cutoffs, and then we're going to put a certain amount in each tail of the distribution. In this case, we have 16.35% in each tail. So we're saying at least as extreme as our Z-score. What percent of scores are as extreme or more extreme than our Z-score? And so we would add these two values together, and it would give us 32.7%. We could also look at a percentile for a negative Z-score. And like I had said before, let's say our negative Z-score is negative 1.82. You can just look it up as that percent in tail. The other way you could do it is if you looked at that mean to Z area, then you could take 50 and subtract out that 46.56%. And it would give you 3.44%. If we wanted to know what percent fell above a negative Z-score, you can see why this might be important to draw some of these pictures. You still have the same cutoff here, but when we start talking about above a negative Z-score, then we have to add in this whole half of the distribution that we're not working with, and we have this 46.56% that's mean to Z. So that gives us 96.56% of the scores fall above a negative Z-score of 1.82. So that's how you use a Z table, and you determine what the percentile is for a particular score, and also what percent of scores fall above or below a given score using the Z table.